Hello everyone. First of all, I want to thank Google DevFest for having me, and today I want to talk about a few base applications with Conductor. So my name is Simon, and I'm an Android developer at Foundry. Foundry is a consultant agency located in Antwerp. And we believe in good and strong performing apps, strong architectures, and clean and multi-site code. So what I want to talk about today, I want to talk about Android lifecycle, master detail pattern, and how we do this in Conductor, animations, and as a bonus topic, I want to talk a little bit about Anko. So lifecycle, something you all have to deal with in Android. And first of all, the activity lifecycle is one that you have to deal with, but it's pretty straightforward, so I won't go too into depth about this. And then second of all, we have the fragment lifecycle, and this is a screenshot of the fragment lifecycle from the Square article advocating against fragments. It's quite complex, but if you're used to it, it's not that bad. The talk today is not dedicated that fragments are bad, so I don't want to go too into depth about this too, but something annoying that we probably all dealt with before is fragment exceptions. There's a lot of funky stuff going on in the fragment managers, transactions happen asynchronously, and this can cause a lot of trouble. So there's a third lifecycle in Android, which is the view lifecycle. And it's very simple and very straightforward. And a view has three states, which is a created state, which is when you call the constructor, an on view attached to window, where your view is attached to the window and it's visible, and when it's detached. And why we want to do view-based applications is due to this. Anything you do between unattached and undetached cannot cause any errors. You're allowed to do anything here. Even if your view is in the background, you can still make changes to the view and it will not cause any exceptions. And I took a look at the view class file, which is about 22K lines of code, and there are 5 exceptions in those 22K lines of code. And all exceptions are related to setting a click listener when it's restricted. So that's something you control, so views are good and are easy to use. Has anyone here ever considered using a view-based navigation and made custom view apps? No? Okay, some people. So the Conductor lifecycle is very similar to what we just saw for a view. We have an uncreate view, an unattached, an undetached, and non-destroy. So basically, you have the 3 same states as you have for a view, and 4 if you consider destroyed a state. And this becomes very important maybe in the near future, because Android N has multi-window, and some problems may rise with that. So, for example, the multi-window does not add any lifecycle events. So it becomes hard to detect when you are in multi-window and what you should do. First of all, when you have 2 apps open like here, one app is considered topmost, and this app lives like any normal app in the foreground would. But the other app is considered in the background, so it lives between on pause and on stop. And for example, in this demo, if you are handling the bottom app, that one is in the foreground, the top one is in the background, so most of all we stop all resources related stuff like playing a video and on pause. The video would stop playing, which is kind of ridiculous because you still want to see the video playing. So what happens in multi-window is a configuration change, like from landscape to portrait or the other way around. And because in the bottom one, which is a Conductor demo, we can do anything between unattached and undetached, and because the app is still visible, the view is of course still attached to the window, so no special changes have to be made. So the master detail pattern. Probably one of the most used patterns in Android. We have some data. Oh. That was a video, it's not playing. You have a list, you click on an item, you go to a detail pane. Perhaps in landscape you have a 2-pane view, which you have your list on the left side, the detail view on the right side. It's, oh, this one plays video. So something similar to this, and this is an experience that I personally like. Even as a Fablet user, I want to have that tablet experience in landscape. So I generated the master detail pattern in Android Studio, and a bunch of generated code came out, and it looks something like this. You get an item activity, and if you're in a landscape, you have a two-pane view, and you place a detail fragment within the detail view, and or you go to an item detail activity. And if we take a look at the source code, it looks something like this, and this is a lot of code, but basically it's a container with a toolbar inside of it and a frame layout with an item list. And depending if you're portrait, you just get a recycler view, or if you're landscape, you get a recycler view with a detailed frame layout which you can push your fragment inside of. So how can we do this with Conductor? First of all, Conductor is a project by Blue Line Labs. It's a small company located in Chicago, USA. And I want to say something about their GitHub. They have an amazing demo on there, and they have almost anything you want to do with view-based applications available in their demo. So if you take a look at their GitHub page, this is what it says. It's a small yet full-featured library for building view-based applications. And it provides a lightweight wrapper around the standard Android views. So what are the advantages? If you want to do view-based applications, you would have to write a lot of boilerplate code to do your backstack navigation, animations, etc., and Conductor takes care of all of that. It's easy to integrate, simple but powerful lifecycle. Backstack navigation is handled for you. They put a lot of effort in state persistence. They have an amazing system for doing transitions and animations, and everything you need, like callbacks for unactivity resolve, unpermission resolve, are available to you. And what's cool here is it's open to any architecture you could be currently using, like MVP, MVVM, Fiverr, MVC, anything. And Conductor is split up in 3 dependencies. And you have the core dependency, Conductor, which holds a Conductor library, and a lint checker for any Conductor-related lint checks. And then they have 2 additional libraries support, which is basically a view pager for using view pager with custom views, and Eric's lifecycle. Does anybody uses Eric's lifecycle by Trello? All right. So Eric's lifecycle by Trello is basically a library that allows you to bind your Eric's or observables to the lifecycle of an activity or fragment. Blue Line Labs provided a way to do the same thing for a view. So Conductor is built on 4 key components, which is the controller, which is your view, the router, which takes care of all your backstack handling, controller chains handler, which takes care of animations and transitions, and a router transaction. And I want to talk more in depth about this. So first of all, how are we going to implement the master detail sample we just saw? One key difference here is we're using a change handler frame layout, and what that does is it blocks all interaction between the change between 2 views. So here they're going to check if a change started and the change completed, and they're going to intercept all touch events between that change. And what I like about this, and this is something I've had with Fragments before, if you changed a fragment, I was able to click on a fragment that was not yet drawn. And that's some behavior we absolutely do not want. So we're going to start implementing this, and I stripped some code of it, some butter knife code, some toolbar code. We're not interested in that today. So first of all, we're going to set up the router that handles all backstack navigation for us. And we do this just by passing the activity instance, the container we want to place our views in, and the saved instant bundle. And Conductor checks here if it has to restore a previously used router, for example, on a configuration change, or create a new one. And in the case that we have recovered one, we want to check if a view was already set as a root. And the root controller is basically the view that's at the bottom of your backstack, and it's the last view you want to see when navigating back out of the Backstack. So last of all, we want to pass all the Backstack navigation to the router. So it's pretty straightforward. Any questions so far? So this is what we all wanted to see. How do we build our views? And we inherit from a base controller, and we must implement either a non-argument constructor or a constructor that takes in a bundle. And everything you pass into the bundle is arguments you want to retain over configuration chains. This is something that should not be unfamiliar. We do the same thing with fragments. So, and I stripped some code here too, code we're not interested in. Basically, this is also what you would do in a fragment. We're gonna inflate an XML layout. We're gonna bind it with butter knife. We can do some setup for the recycler view. And on the underscore view, we're gonna unbind our view. So again, pretty straightforward, nothing unfamiliar so far. And this is unattached. This is the lifecycle event we talked about earlier, the same as a regular view we get. And Conductor works really close together with the view, and this would just get called when your view is added to the container that we created in our main activity. And I take this opportunity to fill my adapter with some data, and you should not do it like this because this is blocking code. This is just for sample purposes. But it would be a good place to, for example, fill your adapter. And let's say I configured everything correctly, and this method gets called when an item in my recycler view is clicked. So what I'm going to do here is pretty straightforward. I'm going to get the item from my adapter, and then I'm going to call a method called show detail. And this is where I create my detail view controller. And behind the scenes, I'm just putting all this data in a bundle and passing it to the bundle argument constructor. And then I'm going to pass a change handler. And what this looks like is something like this. So I was already talking about the two-pane view and a single-pane view for master detail in landscape portrait. So first of all, I'm going to check if we're in a two-pane view layout or not, and I'm going to determine that to see if the detail container is available, yes or no. And in case the detail container is available, so we're in a two-pane view, I'm going to get a child router. It's just similar as a child fragment manager. And basically what it does is I'm going to create a new backstack within my current controller. And I'm going to place a new controller in my current controller in that detail container, just like you would do in any regular setup. And if we're not in a two-pane view, we want to change to a completely new view. So we're going to do that with the main router. And this is also pretty much everything I can say about a router transaction. A routing transaction is just some metadata that the backstack keeps to know what was going on. And we can do four things with it. We pass a controller we want to change to. You can place a tag, just like you can do with fragments. And you can declare a push and a pop change handler. And we will talk more in depth about change handlers in just a second. But by doing this, the controller or the router knows what animations or transitions it should play when doing push and pop. So animations. Animations are becoming very important. Again, explain. We don't only care about high-performing apps, fast apps. We also care about meaningful motion, and it can contribute to a richer user experience. We want our apps not only be high-performant, but also to look good and feel good to the user. And by using animations, you can make your app feel more fluent, and it will feel more natural to the users. And this is becoming more and more important every day. So again, traditionally, and this is something very popular, shared element transitions. And if you do it the traditional way, and I know you can also do this in code, but 70% of all the stuff you will find online is going to tell you to do it in XML. So this is a small XML example of a transition with a change bounds and an arc motion. But we will talk more in depth about that when we see the Conductor way to do this. And normally in your code you will see something like this. You want to do a fragment transaction, and whether it's lollipop or not, you're going to do a transition or an animation. And we have to do this everywhere because I don't think anyone has a min SDK of lollipop. Anyone? No? That's all. So what do we do? First of all, if it's post lollipop, we can inflate the transition, we can set the shared element transition, do a fade in, fade out. Should be pretty familiar to anyone. And in case it's not, we can do some horizontal sliding slide out. Pretty straightforward. Now, and I really like how Conductor handles this. In Conductor, this is all handled by the controller change handler. And it's based upon 3 key components. This is a simple swap change handler, which will just swap your current view with a new view, and there's no animation going on. Just like if you do a fragment transaction, nothing happens, you just simple swap. And then you have an animator change handler, which is everything pre-lollipop. And this is based upon the animator object, which is also used for animating views. So anything you can do with animating views, you can also do with Conductor, which is really cool. And out of the box, you get 3 change handlers, which is fade, and horizontal and vertical change. And then we have the transition change handler, which is post lollipop, which uses transitions instead of animations. And we also have a compact version for this. And out of the box, you get auto transition change handler. Is there anyone here that knows auto transition? Right, cool, somebody? This is something that's available in Android, and I didn't know until I started digging into Conductor. Basically what auto transition does is it calculates the difference between your old fragment or activity and the changes in your new activity or fragment. And if you have shared elements set, it will animate those, and it will fade out the views that are gone and fade in the views that are new without any setup. So I thought it was pretty cool, and I didn't know it. So if you don't know it, it's pretty cool. And then I already talked about the extensive demo by Conductor, available on GitHub. They provide you with 4 extra change handlers, which you can just steal. And I will also talk about change handler you create it once and use it everywhere, which is really cool. So you have a flip, a scale fade, circular reveal, which is also becoming very popular, and a compact version of that. And an arc fade move, which is essentially the shared element we just saw. So we're going to try and make the same animation that we just saw, the shared element one with the fade in, fade out. And we want to fall back for the horizontal slide in, slide out. So we do that by creating a transition change handler compact class. And all it does is take in a transition change handler and an animator change handler for post and pre-lollipop. And it takes care of all the SDK checking, etc. for us. So you can essentially move all that code, either if you have it in the navigation class or directly in your fragment. You can just move that through change handlers. So first I want to talk a little bit about the animator change handler, which is based upon the animator class. And we have to implement 2 methods. The get animator, which you will create your animation within, and the reset from view. And what is key to know here is that we always have 2 views. We have the to view, which we're animating to, and we have the from view, which we're animating away from. And the reset from view, should be clear now, is a method that's called after the animation is done, and you can reset the view you just animated away from. If you want to do a fade and you want to reset the alpha or something like that, reset its position, whatever. So, and I made the code a little bit smaller, and here I only implement the push code. So essentially, if you want to pop code, it's just going to be the other way around. So we get a few things here. We get the container where views live in. You get the from view you're animating away from. You get the to view where you're animating to. You get a boolean for push and pop. And you get a boolean to know if it's already added to the container, yes or no. So here, first of all, we're going to check for the push, because we're only implementing the push. And we're going to do some null checks on the from view and the to view. And next, we're going to create an animator set, and in an animator set, you just play your animations. And first, we're going to say in animator set play, and we want to do a translation on the x-axis because we're doing a horizontal change. I want to slide it in. And here we're going to assume that all our views are mesh parent in our container. So we're going to say the view we're animating away from, slide that out over the whole width. So now it is out of our view. And simultaneously play an animation that slides our new view from out of screen in screen. That's basically all it does. So it's pretty easy to implement any animations you want. Anything you can do with a view animation, you can do in an animator change channel, which is pretty cool because that class is pretty flexible. So for a transition change, and it's even more easier, you only have to implement one method, get transition, and we have the same stuff available on our container, our from view, our to view, and push or pop. So here we're going to implement our shared element, and it's essentially the same thing as we saw in our XML. For one exception, the fade in, fade out that we declared on our fragment transaction can be declared within our change handler. And basically what we're saying is sequentially play fade out, then play an animation, a transition set, change bounds. So it's going to move our floating action button from the bottom to the center, and then do a fade in for all remaining views. And then you can declare bat motion, which you want to be arc motion. You have that nice arc motion and transition. You can declare an interpolator and a duration. So that shouldn't be anything too unfamiliar. Some people already do these in code instead of XML, and that would be doing the exact same thing as we do here. So to recap, we made our arc move change handler, which is our shared element transition, and our animator change handler, which was our horizontal slide in, slide out. And now you can just pass that object to your router transaction, and everything is done for you. The SDK checking, the change, everything is applied, everything comes out of the box. And the cool thing is, if you make one like this, you can put it anywhere on a GitHub page, you can put it online, and you can pull it in with a Gradle dependency. So you don't have to make all of these again. If you're doing some funky animations specifically for your app, you can put it online, even private, and you can do it in all your apps without writing them again. So, as a bonus topic, I want to talk about Anko. Is anyone here using Anko? Anyone knows what it is? All right. Anyone here using Kotlin? All right, some people, cool. So, Anko is a library by JetBrains, developed in Kotlin. And basically what Anko is, it offers you a lot of extension functions on Android. So stuff that we normally would do ourselves are available to you out of the box. But more specifically today, I want to talk about building layouts with Anko and why this is so neat. When traditionally we build all our layouts in XML, and when doing so, the XML gets pulled at runtime, gets parsed, and element by elements get inflated and added. And this costs a lot of time. This is all just overhead. We don't need that. So we're going to try and cut out that process and just build it at runtime ourselves. So a while back, I did an app which had a quite advanced layout. It has to be skeuomorphic. It had to look exactly the same on all phones. And for Android, they can be a trouble because we have a million kind of different form factors. So we did it pretty neat. We pulled it apart, and we ended up with something like this. And basically, it was one relative layout with 17 image views, all having drawables, a custom view, 2 text views, and a surface view for the camera, and a regular view. So we still only have one container, so no necessary containers going on here. And what I did was I translated that XML layout to Anko and I did some performance testing. And this is the result I got. I took 4 phones, which in the eyes of the developer are probably low-end phones, but a couple years ago we were all using phones with specs like this, and we thought they were great and fast. So I don't think they're too bad, but I think we can all agree that these are phones that we all have to deal with every day as an Android developer. So you can immediately see that the difference ranges from 350% to 600%, which is not nothing. And today I want to convince you to at least try out Anko. It's pretty easy to use, and I hope I can convince you, because you cannot deny the fact that there is a big difference. So again, to the layout you saw before, we have a coordinated layout as a container with a toolbar and our frame layout. So normally in your activity we call set content view, and you will pass your XML layout. Now what we're going to do is we're going to start a block, which is a coordinator layout, and we're going to directly set our attribute fit system Windows 3. Within our block of our coordinator layout, we have our app bar layout block. And by default, besides the root container, everything is set to wrap content. So here we're going to set the width to match parent. So still not a big change compared to XML. And within our app bar layout, we're going to place our toolbar. And what's cool about this, and I'm going to say this a couple more times, is we're building our layout at runtime, so we can do our SDK check here to put our elevation on our toolbar. And I think this is something every one of us already saw. If you try to put an elevation in XML, lint is going to say you have to put it in a separate layout directory, specifically for post or pop. And you can do this at runtime. And also here I'm calling a method called action bar size, which returns me the size of the action bar for a specific device. So below our app bar layout, we're going to place our frame layout, and I'm going to put the scrolling behavior on. Then there's one more thing. In XML, you normally have to cast all your views. You have to do find view by ID, and find view by ID is going to go through the view hierarchy and find the view with ID, which is again overhead and not type safe, because you have to do casting. And here, because you're building it at runtime, it's type safe, and you can just assign your views to your properties, which is again pretty neat. No more casting. So if you take a look to compare the XML versus Anko, you can see that there's not much difference. You just call a code block instead of an XML element, and you can just access all the methods directly from your code instead of setting attributes. So not that much different. So there was one more problem. We had this big code block in our activity. And to me this doesn't feel right, because there's more code in your activity, you don't want all that extra code there, and your activity shouldn't really be responsible for building your UI. So let's try and extract that someplace else. So I'm going to make a class master view layout, and just like Butterknife, you're going to have a bind method and an unbind method. And the unbind method just puts all your property values to null. So again, pretty straightforward, nothing special here. And in the bind layout, we're going to start a UI block. And in the UI block, we can get the view and return it, and we can start building our layout just like we did before. But Anko again offers something special here, because we've been talking about the master detail pattern. And normally you do this in two separate XML files. So how do you do this in Anko? In Anko, you have a method called configuration, and basically it's just a fancy if. You can pass a lot of named parameters here, like orientation. You can check at runtime, is the device imported? Is it a landscape? Is it a tablet? Is it a square UI? What's the width? What's the smallest width we should show? Stuff like that. Is it right to left? Day and night modus, whatever. You can do all those checks here, which is pretty neat. And important to just add our recycler view. So we have that here. And then in landscape, you have a recycler view and a frame layout. And that's it. We have just combined just two different layouts in one place, which is pretty cool. And again, we can just directly assign our properties. And this might be a little weird, but it's exactly the same as Butternut does. Your properties are protected instead of private, and you can just directly assign them. So I want to emphasize this one more time because this might actually be my favorite feature of Kotlin, is that you're building your layout at runtime. And it's been a numerous times when I was using XML that I had to feel like shit. I want to do some logic. Depending on what's going on, I want to build a different layout. Building your layout at runtime solves all these problems for me. So for example here, and I know the percent layout that Google introduced solved this problem, but here I just call a method width 50%, and it's going to calculate 50% of my screen and assign it as a width. And you can pretty much do any logic while building your layout, which I think is a great feature, besides the enormous performance boost you get. So, are there any questions?
Don't have any preview for Anko if you want to
there is a IntelliJ plugin for the preview, but with the new update of the new preview, it broke, but they are working on it to fix that. But to me, it is really an issue because I was always building my views in XML. But beside that, if you really want to use the preview for such an enormous performance boost, it takes like a couple of minutes to translate it from XML to Anko, if that's really the issue. We spend hours and hours to do everything on back threads, using RX to boost performance, and stuff like that. So in my eyes, this is just a little effort to make a big improvement for your lower end users.
Does it support lifecycle layout?
Currently it does not, because it was just released this week in beta, and they decided not to support it until it is officially released. I must add, building extra functionality for Anko is extremely easy if you're familiar with Kotlin, because basically it works upon the whole extension method system. So if you want to implement it yourself, it's probably not going to cost you more than half a day, maybe even less. Any more questions? No? All the code you saw today is available on my GitHub page. And I want to emphasize again, Conductor has a great demo with almost everything you can do with Conductor right on their GitHub page. So it's pretty cool.
Yeah, just one thing. There are two libraries from Square that are called Mortar and Flow that seem to do exactly the same thing as Conductor, but I'm not sure if you know.
There are different libraries out there. There's Scoop and there's Flow and Mortar. Flow and Mortar has stopped seeing development there or progress there for almost like 10 months now. That's the reason that I checked out Conductor. And then there's another option, which is Scoop. But the thing with Scoop is they build it for the in-house company and they open sourced it. And all the features that are not available in Scoop, you have to implement yourself, which is a pain. And Conductor is really fully featured and really easy to integrate. If you're using Fragments, you can almost just copy your code to your view, and it should be enough to migrate.
Thank you.
No more questions?
So, yeah, zero transaction. So contrary to Fragments, you have no transaction.
Yes, you do have.
Immediately applied.
Yeah, it's immediately applied. So in the Fragment Manager, the transaction is asynchronically, but because a view is just removing a view and adding a new view, it's so fast that they don't have to do it asynchronically, and you will not see any performance loss.